Hi everyone. This lecture gives you the basic concept of logical addressing in network layer. So these are the content. So at the end of this lecture you will be familiar with these terms, and I have given the detailed explanation about cider and masking in my next lecture entitled masking. So let's get started. We all know this network layer is responsible for making communication between host to host, that is from one computer to other computer across the globe, which means the packets will be sent via computer will pass through several LANs or WANs before reaching the destination. So for this we need a global addressing scheme to identify each and every devices which are connected over the internet or the network. So that particular address is known as Internet Protocol address. So actually it is nothing but it is an address of TCP IP protocol suite. Now let's have a definition of this IP address. So this IP address, most probably IP version 4, it is a 32-bit length address which uniquely and universally define the connection of a devices to the internet. That is, we can have the maximum of 2 power 32 address by this IP version 4. Here, unique in the sense no two devices can have the same address, and universe in the sense it will be accepted by any host or devices which is connected across the globe through internet. So now, due to demand of addresses in many organizations, now this IP version 6, the other version of IP address, has evolved, and this is 128-bit address. And this has many advantages, like it gives or it have greater flexibility in address allocation. Now let's see what is this address space. So few seconds back I have told that this IP version 4 support the maximum of 2 power 32 address space. So the address space means it is nothing but the total number of addresses which is used by the protocol, that is IP protocol. For example, if n bits are used to represent the address, then the address space will be 2 power n. So here you can see the address space of IP version 4 is 2 power 32, or it will give this range, which means some more than 4 million devices can be connected via using internet using this IP version 4. Now let's see the notations which is used by this IP version 4. Actually there are two notation, they are binary notation as well as dotted decimal notation. In binary notation, this IP address is displayed as 32 bits and each octet is referred to as a byte. That is, you can in this example you can see all these 4 bytes, that is all these 4 bytes are represented as a 32 bits with 8 bit separation. So we can call this as a 32-bit address or 4-byte addresses. And the next notation is dotted decimal notation. That is, the internet address are usually written in decimal form. That is, you can convert this binary into decimal form with a decimal point, that is dot, which separating all these bytes. So we have used this dotted decimal notation normally because it is easier to remember as well as easier to read. Here you can see in this example, so the bit representation, that is 32-bit representation of IP address can be converted into decimal notation. Just you convert this binary into decimal. Now let's see some of the examples of this binary and dotted decimal notation of this IP address. Here you can see the IP address is represented as a 32 bits and they are separated as 8 bits each. So you have to convert this binary representation of IP address into a decimal form. You just convert each of this binary into decimal and just place dot in between each byte. So this is the answer for this particular question. And you can do this as an exercise. That is, you can change from this decimal notation, you have to convert that into binary. You simply convert each of these values into binary and you just get rid of this dot. And now we can find if there is any error in this following IP addresses. So here you can see actually it is an error because these bytes should not be preceded by a leading 0. And here we all know it is only 4 bytes. Here they have represented some 5 numbers, so it is an error. And also here the each number or each byte should be less than 255. The range is from 0 to 255, but it is exceeding this 255. And here you can see you cannot use a mixture of both this dotted decimal as well as this binary notation as a combined one. So again this is also an error. Now let's see the addressing scheme which is used in this IP address. So the old addressing scheme which is used is this classful addressing. That is nothing but you are giving just a classification to the addressing. Actually this type of addressing is almost obsolete. That is, we are not using this. We are using only the classless addressing. That is, you can read from this. In classful addressing, the address space is divided into 5 classes. That is, you can divide the addresses into 5 classes like A, B, C, D and E, and these are the ranges for these classes. That is, class A occupies from 0 to 127, class B this range up to, so it starts with 0 and it ends with class E with 255. And we can say which class the address belongs to by identifying first few bits of the address in the binary notation, as well as in decimal notation we can identify which class that particular address belongs to by just noting down the first byte. Likewise, we will see some example regarding this. You can see here they have given the IP address is in both binary as well as in dotted notation. We have to find which class this particular address belongs to. So in the first example you can see the first bit start with 0, so it must be class A address. You can check this. So in binary notation, the first few bits you can identify which class the particular address belong to. Whereas in decimal notation, you can identify which class the address belongs to by just looking on to the first byte. So here again you can see you can see the first 3 bytes, it belongs to the class C. You can see. So the first 2 bits are 1, the third bit is 0, so it is a class E address according to this notion. And in this decimal notation, you can see the first byte is you have to look only to the first byte. So since it is 14 and it falls under the range of this 0 to 127, so you can tell that particular address is class A. And same for this 252, actually it is in the range of class E, so you can say this particular address belongs to class E. Now let's see the classes and the blocks. So actually the problem with this classful addressing is each class, that is each 5 class of classful addressing is divided into fixed number of blocks, and each block is its block size. That is, in classful addressing, the larger part of the available addresses were wasted, which means the class A address is mostly used for large organization like attaching the host or attaching the router or something. And this class B is used for mostly for the mid-size organization. And this class C was used for small number of organization. And the thing is, the class A is too large for any organization, so many of the addresses get wasted, which means they are not used. And also this class A is very much too small for a small organization. Again the address gets wasted. And you can see in class D it is used for multicasting, which means sending the information to the group of destination computers through IP addresses, which means single sender and multiple receiver. And this range, some 2 crore range, these groups are not actually needed, and so again the IP address gets wasted. And you can see the class C, actually it is reserved for the future use. Again there comes the wastage of the wastage of these addresses. The thing is, actually this presentation is based on the book Data and Networking, which is written by Ferozon. So actually it was written in good old days. The thing is, the reason I'm telling is now we are using only, most of the devices are using IP version 6 classless addressing. It is evolving and we are using that. And this classful IP version 4 is almost obsolete, which means all this the class A address which is used for which is reserved for future use, we have used already. Now let's see what do you mean by this net ID and host ID. That is, the IP address of class A, B and C is divided into net ID, network ID, as well as host ID. Host ID in the sense the device where the packet has been arrived or where the packet has been sent. So here you can see in this figure the net ID is represented as in color boxes and host ID is in white. And again you can see this concept of classification of this net ID and host ID is not applicable to this class D and class E. So the example you can see in class A, the first byte, 1 byte defines a net ID and the remaining 3 bytes will be the host ID, right? And here in class B, the 2 bytes represent the net ID and the remaining 2 bytes are host ID. And in class 3, the first 3 bytes are net ID and the last one is a host ID. So this particular classification of an IP address gives the exact location where the packet has been sent and it will be received. Now let's see what is mask. In my next lecture, I have given the detailed explanation about mask and how to find the subnet network likewise. So here, in classful addressing for classes A, B and C, we will use this mask. This is a default mask. It is a 32-bit number made up of continuous 1 followed by the continuous 0. Actually, it is not applicable to class D or E. The purpose is it is used to find the network ID as well as the host ID. Here you can see in this example, the mask for class A address has 8 ones, which means the first 8 bits of in class A used to define the net ID and the remaining 24 bits is for the host ID. Likewise for class B, the first 16 bits are used to identify the net ID and the next 16 bits used to identify the host ID. And you can see in the last column, we have represented some number using this slash. So this representation is known as a CIDR, that is classless inter-domain routing. It is used to identify the subnet IP address in case of masking. So we'll discuss about this CIDR in more detail in my next lecture. Next is subnetting. Subnetting is a process of logical subdivision of the IP address. That is, we are dividing the IP address or we are dividing the network into subnetwork. So the division of IP address, that is logical address, into 2 or more networks, shared network addresses is called subnetting. And this division of this network into 2 or more subnetworks yields 3 parts. They are the network ID, subnet ID as well as the machine or the host ID. So you can see in this example, here this IP address belongs to the class B. The first 2 bytes represent the net ID and the last 2 bytes represent the host ID. And we are dividing this into a subnet. That is by taking the portion of 8 bits of this host ID. So we have the net ID as such and the host ID as this 5 and the subnet ID is this 25. The purpose of dividing this, purpose of dividing this organization network into shared network addresses is it reduces the wastage of IP addresses. That is, by getting the separate IP address, we are using it at full in an efficient manner. The next is supernetting. Actually, this technique is almost obsolete now. We are not using. Now, the modern internet is classless IP address. That is, we have subnets as well as the prefixed. In subnetting, we have seen dividing the network into subnetwork. Whereas in supernetting, it is an aggregation of this subnetwork. That is, we are combining or aggregating the multiple subnetworks to form a network. And this term was coined to describe the act of combining multiple classful networks which is violating the class boundaries. And it was introduced during